Hey folks, welcome back to Chapter 5. We have spent a couple of videos, a couple of days looking at F net equals ma, a very important equation in physics. Today we are going to look at some questions that are still actually F net equals ma, but I think you might like this lesson. It's a little bit more straightforward. We're going to talk about tension and pulleys. Tension is the force present in a string. So we've seen lots of different forces in this chapter so far. We're just going to call it F with a little subscript capital T for tension force. So I've got a simple free body diagram here, a mass hanging on a string, and I would ask you, hey, what are the forces acting on that object? Well, we've got the force of gravity pulling down, m times g. And then we could look at that and say, well, it's not accelerating into the center of the planet. So there must be some other force acting on it as well. And it's actually the string holding it up. It's kind of like an elastic force when we saw the examples of an object dangling on the end of like a bungee cord, a radical dog. But in this case, the string we're going to say isn't stretchy. So we're going to say, hey, there's a tension force. And if that object is simply just dangling there, I bet you can guess what's true of those two forces if we compare them to each other. They would be exactly the same. Now, tension and pulley questions are not going to look like this all the time because that would be boring. If I said, hey, let's go and plug in a, what could we make it? Let's make this thing 3 kilograms, just for fun. If we made this thing a 3 kilogram mass, then we'd say, okay, that's 3 times 9.8. We'd grab our calculator and we'd say, yeah, that is 29.4 newtons of gravitational force. And since that object is not accelerating anywhere, then the tension force has to be the same, 29.4 newtons. That's easy, but it's boring. If you had to do question after question like that, like what's the point? What are we doing? So I'm going to take you through tension in a string where we loop a couple of masses on either end of a string over a pulley. All right, so let's try this question out. We've got 2 dogs. They're both humanely harnessed. Don't worry. With these tension and pulley questions, I think you're going to like these because the past few lessons we've been looking at all kinds of variation with F net equals ma. There's been like tons of different types of questions we've gone over together in the notes. You're going to see even more questions, different ones when you go through the practice. If you haven't done the practice, make sure you do. The cool thing about tension and pulley questions is they always set up the same way. We always find the same 2 things, the same way, in the same order, every time. So here it says find the acceleration of the system and the tension in the string upon release. So we're going to humanely harness these dogs on either end of the string, loop it over a pulley. We know the big dog's going to accelerate downwards. We know the little dog's going to accelerate upwards. We will stop the pulley system from spinning before the little dog gets sucked through. So don't worry. No dogs were injured in the making of this question. So here's what we do. Step number 1, always, is we find acceleration. So let's shorten up that big title. Let's just say find A. And in order to find the acceleration of the system, you have to use both the masses. I'll say masses. I put dogs in there just to spice things up a little bit. But usually it would just be masses. We have to use both masses. So let's look at this picture here. You could just draw the dogs as blobs or something unless you've got some artistic ability. Let's talk about the forces acting on those dogs. I would say that, hey, on each dog, you've got the force of gravity acting on them, m times g. And since we know the mass of both of those dogs, we might as well grab our calculator and find that. 8 times 9.8 is 78.4. And 32 times 9.8, the German Shepherd's quite a bit heavier, 313.6. And for newtons, now that better not be the only forces acting on these 2 dogs, because if it is, they're going to go accelerating towards the surface or center of the earth. We don't want that to happen, right? No dogs were harmed. So what's happening in this case is the dogs are being held up by the tension in the string. And the cool thing is, because we're letting this system spin on a pulley, that tension force is going to be the same. You don't have to find it separately for the big dog and then separately for the small dog. So this is what our free body diagram looks like for this setup, for any time you've got two objects attached with a string on a pulley. Let's think about this now then. If that's our picture, what's going to happen with F net equals ma? So what we've actually got here is like two different objects that we have to look at. Let's look at what's happening with the big dog. So we're going to focus just on the big dog for a moment, just this scenario. I would look at that dog and say, okay, what's the net force acting on that dog? And we've got a little competition here, so we're going to, competing forces, we're going to do a subtraction. And I like to do the winners minus losers. We know this big dog, when you let the system go, the big dog's going to accelerate downwards. So it's the force of gravity on the big dog fighting against the force of tension. So that's what's happening just for the big dog. So I'm going to put that in brackets. But then we've also got what's happening with the small dog. So I have to add that. It's a bit of a special case of F net equals ma. So if we look at the small dog, we've got the two forces competing. We're going to do a subtraction. Let's do winners minus losers. Remember, the small dog is going to accelerate upwards. So this time we know that the tension force is the winning force. And it's fighting against the 78.4 newtons downwards. I'll just lower this a little bit to make it cleaner. So that's equal to, don't be fazed by what's going on there on the left. We'll clean that up. It'll be quite nice in a moment. We did look at both of the dogs. We said use both of the masses in this question. So when I go to plug in m in my F net equals ma, I actually have to add the two masses together. The big dog and the small dog. And then we're trying to find acceleration. And you might look at that question initially, this question initially, or equation, and say, well, what the heck, Heinrich, there's two unknowns. We've got an unknown acceleration, which we're trying to find, and then what's going on with this tension force? We don't know that yet. But I want you to pay attention to the tension force. You've got a negative tension force on the left plus a positive tension force. So the math is actually pretty slick. Because those tension forces are pointing in opposite directions, one's negative, one's positive, they're actually going to wipe each other out. And what we're left with, hopefully this makes sense, is you've got the force of gravity pulling down on the big dog, and the big dog's force of gravity is having to fight against the small dog's force of gravity because it's dragging it along. And that's what the math here says. So we're going to cancel those tension forces. 313.6 minus 78.4 means the left-hand side is 235.2. Equals 40 times a. We're down to just one unknown. We can quickly find that acceleration. Divide by 40. 5.88 meters per second squared. So there's your acceleration. We used both dogs. The tension forces canceled out. And the cool thing is, the only change you'll ever see with these questions is I change up the masses. I change the numbers on you. So you'll actually be able to cancel those tension forces every single time. So in the next example we do, maybe we won't even put them in there, just because we know they're going to cancel out. So that's actually part one. We found the acceleration. Now we have to find the tension force. So let's try sort of part B, or part two of this question, which is to find that tension force. Find Ft. This is always step number 2 in these questions. Now, you might recognize that we won't be able to look at both of the dogs, both of the masses again, because if we do that, the tension forces will cancel. So in this case, we're going to pick only one of the dogs. one of the masses, and I would recommend that you pick the smaller mass. I'll point out why sort of at the end of the question. It turns out you could pick the bigger dog as well, the bigger mass. It doesn't really matter, but life is a little bit easier with negative signs if you pick the smaller of the two masses. So let's go back to Fnet equals MA. We are now looking at only the small mass, which is only the small dog. Remember, we already played this game. We said what's happening with the Fnet? Well, the little dog's going to accelerate upwards, so it's tension force fighting against the force of gravity equals, now don't use the combined mass of 40 kilograms anymore. We're just looking at the small dog. Number one mistake is probably that right there. Right? We are only picking the small mass. Don't put the combined mass in. Times acceleration, which we found in the first part of the question, 5.88. And you are mathematically just an easy addition away from having the tension force in this system. Add 78.4 to both sides. Let's grab the calculator. 588 times 8 plus 78.4. 125 to get our 3 sig figs. 125 N for newtons. So that is always how tension and pulley questions set up. That is always how they're going to go. Let's try one more together, and then I'll turn you loose to try the homework that goes with this lesson. So here we'll balance things out. I don't know, maybe you're a cat person more than a dog person. So let's make example number 2, some cats. You can see here part A and part B, we want to find the acceleration, we want to find the tension. We always find those two things in that order. So let's turn this into a modified free body diagram. We've got the force of gravity acting on both of these cats. One bigger, a little bit bigger, one a little bit smaller. So we'll probably get a smaller acceleration out of this one. So there's the big cat force of gravity. Oops. The small cat force of gravity right there. So 41.16 and 34.3. And then we also have the string pulling up on both of these cats. Otherwise they would just free fall down towards the ground. These cats, again, humanely harnessed. We will stop the small kitten from getting sucked through the pulley. Nobody hurt in this question. So for part A, we're going to find acceleration. Find A. And this is a modified Fnet equals MA. Remember, there's kind of a shortcut here. The shortcut is when you go to play the game and you look at the forces with both masses. I should put that in again. We're going to use both cats. Those tension forces will cancel out. Actually, maybe one more time I'll keep them in there just so you can see it. So I'm going to look at the big cat first. I like to start with the big cat. I know that the gravitational force is the winner because that big cat's going to accelerate down. And that force is fighting against the force of tension. Plus, we have to look at what's happening with the small kitty. We've got, in this case, the tension force is going to win. We know that cat accelerates up. It's fighting against the 34.3 newtons of gravity. Equals, we have to combine these masses. Sorry, I'm running out of space here. Plus 4.2. That looks terrible, but work with me. Times A. The tension forces will cancel because one's negative, one's positive. That works out great. And then we're left with the force of gravity on the bigger mass fighting against or dragging along the force of gravity on the smaller mass. So 41.16 minus 34.3 is 6.86 equals, what have we got? 7.7 kilograms of kitty combined times A. Acceleration is equal to There you go, 0.891 meters per second squared. And for part B, we're going to find the tension. We're going to find Ft. And when we do that, I would recommend looking at the small cat. Oh, I forgot to point out why we picked the small one, not the big one. I'll do it in this one if I remember. Remember that this is also a modified Fnet equals MA, but we are only looking at the small kitty now. So I'm going to stick with winners minus losers, Ft minus 34.3 equals. Now we only put the mass of the small cat in. Don't put the mass of the big one. Don't put the combined mass, just the small mass. Multiplied by the acceleration we had, 89, which was actually 8909, and I'll use that button on the answer button on my calculator. We are an easy addition away from getting that tension force. And I'll have to move off to the side to put it in there, but that's okay. Times 3.5 plus 34.3 equals, it looks like 37.4 newtons. 37.4 N for newtons. Question's done. There's your two answers. So, tension and pulleys, they always set up the same way, kind of cool. I should point out the reason we picked the small mass is because the Ft is positive. If you picked the big cat, you don't have to copy this down, but if I did an Fnet equals MA for just the bigger cat, and I stuck with winners minus losers, I'd actually have 41.16 minus Ft equals the mass of the big cat times my acceleration. It's going to give you the same tension force. You're still going to get 37.4 newtons, but now you've got to deal with a negative Ft, and that's kind of a pain. So it doesn't really matter. I just like to avoid negative signs if I can. So there's tension and pulleys. Hopefully you find that maybe a nice break from what we're used to with Fnet equals MA, because you'll see in the practice, the only thing that changes, I think there's 4 or 5 questions for you to try. The only thing that changes from question to question is the masses there. I will never make you find a different variable. I will never make you work in a different order. I will give you a heads up though that quite often students, because they find this a nice easy break after the last couple of lessons, sometimes students actually don't do a very good job with these on quizzes and tests because they just never even do the practice. So make sure you do the practice. You will very likely see a tension and pulley question on your Chapter 5 test. You're going to need to know this for next year as well. So give the homework a try and come join me for a Zoom meeting if you've got any questions about anything. Take care, everyone.